and this set B, this set can be defined in this way. Okay, this set can be defined in this way. A cross B equals to what? X comma Y such that X belongs to A and Y belongs to B. Here see that this one X comma Y. This is the collection of all ordered pairs. Okay, X comma Y. This is the ordered pair. Okay, and so what is you learned? Uh, Cartesian product is what? It is nothing else. This is the product of two sets, and which can be defined in this way, and this is also a set. Okay, and suppose we consider a equals to suppose 1 comma 2 comma 3 and b equals to suppose 4 comma 3. We consider the elements like this: a equals to 1 2 3 and b equals to 4 5. Then a cross b equals to what? First you have to take 1. Okay, first you have to take 1, the first element of this set. Then you have to form the ordered pair. Okay, then first take the first element of that set. Then suppose we consider 1, then uh, take the other element. The second element comes from the second set. Suppose we consider 1, then this one 1 comma 4. Then after that this is just 1 comma 5. Okay, then we stop. Then one is done. After that we choose the second element. Okay, when we choose the second element is what? 2. Yeah, so this one will be what? 2 comma 4. Okay, 2 comma 4, and other was what? 2 comma 5. 2 comma 5, and we can stop for 2, and the remaining element is what? Remaining element is 3. Then we start from 3 comma 4 and 3 comma 5. So the collection of this one a cross b is like that one. Okay, understand?
Yes, ma'am.
Similarly, we can form b cross a. Okay, we can find b cross a. When we write suppose b cross a, then first you have to choose the element from the second set, this one b cross a. So we start from b. So first element of b is what? First element of b is what?
4.
4. So we start from 4. 4 comma 1, and after that 4 comma 2 and 4 comma 3. Okay, so uh, we can stop for 4, and after that we'll start for 5. Okay, then this one will be like as 5 comma 1, 5 comma 2, 5 comma 3. Okay, here see that a cross b is this one and b cross b is this one. Now see that, see from this one a cross b and b cross a. Now tell me, is it a cross b equals to b cross a? Suppose I write a cross b equals to b cross a. Is it true?
Yes, ma'am.
Is it true? A cross b equals to b cross a?
No, ma'am. No, no.
See this one. A cross b equals to like that one, and b cross a equals to like that. From this one, now tell me, is it a cross b equals to b cross a? Is it true? Is it correct or not? Hello?
Not correct, ma'am.
Yeah, a cross b does not equals to b cross a. Here see that a total number of elements a cross b equals to b cross a. These are same. Okay, but see that first element of a cross b is what? Here the elements of the sets is what? Ordered pair. And see that first element is what? 1 comma 4. And the first element of B cross A is what? 4, 1. And see that 1, 4. This is also a ordered pair, and 4, 1. This is also a ordered pair. But 1, 4 does not equals to 4, 1. Okay. So rule is what? The ordered pairs are equal. Okay. If and only if the corresponding elements are same. Okay. Here suppose first element of this one. First element of this one is what? If we consider the ordered pair 1, 4, then first element of this ordered pair is what? Hello? 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 Hello?
Yes, ma'am.
See that first element of this ordered pair 1, 4. First element of this ordered pair is what?
1, 4.
First element. Tell me the first element.
1,
1.
1, 1.
Yeah, 1. And the first element of the disordered pair 4, 1 is what?
4.
4. Is 1 equals to 4? 1 equals to 4. Is it true or not?
Not, ma'am.
Okay, 1. Yeah, 1 does not equals to 4. Okay, so these ordered pair are not equal. Okay, two ordered condition is what? Two ordered pairs are equal when if and only if the corresponding elements are same. Okay, remember that thing. Two ordered pairs are equal if and only if the corresponding elements are same. Here see that the corresponding element of these two ordered pairs are not same. Okay, so these are not equal. So we cannot say that A cross B equals to B cross A. So this is from this one we can say that commutative law does not hold for Cartesian product. But in case of union and intersection, when we write A union B equals to what? B union A. Both are same. Okay, and A intersection B is also what? A B intersection A. These are same. So we can say that commutative law holds for union and intersection, but commutative law does not hold for Cartesian product. Because what? That is A cross B does not equals to B cross A. On remember this thing. Number one, two ordered pairs are equal when their corresponding elements are same. Suppose we consider the ordered pair xy and u comma v. These are equal if and only if x equals to y and y equals to e. And the number of elements in A cross B is what? If suppose A has P element and B has Q element, then the number of elements in A cross B is what? P into Q. Okay, P into Q. Here see that A is what? A number of elements in A is what? Number of elements in A is what?
3, ma'am.
3. And B has how many
2.
elements? 2. So in A cross B, the numbers of element will be what?
6.
6. 3 comma 2. Oh, sorry, 3 into 2. This is 6. Okay, so remember this thing also. If A has P element and B has Q elements, then the number of element in A cross B equals to P cross Q. Okay, and if we write suppose A cross A, suppose we consider uh, triplet A cross into A. We multiply in 3 times A cross A, then we'll get the ordered triplet, and that is the A comma B comma C, where condition is same. A, B, C are comes from A. Suppose if we generalize this one for n times. Suppose if we write like that one, a1 cross a2 cross a3 cross up to an. Okay, there are n elements. So then it is called ordered nth element. Then that is what a ordered pair. A or this is not pair. A1 comma a2 comma a3 comma up to an. Okay, are you understand?
Yes, ma'am.
First, you have to know about ordered pair, okay? And the Cartesian product is what? That is the product of two sets, okay? Product of two sets is product of two sets is called the Cartesian product. Define. And next, tell me about relation. Okay, relation is what? Relation is a subset of Cartesian product. Okay, in the Cartesian product, see that we collect all the ordered pairs. Okay, collect all the ordered pairs of A and B. Suppose that we collect some particular some ordered pairs from A cross B. Okay, and suppose they are related to each other. Okay, then this collection is called relation. So relation is what? Relation is a subset of Cartesian product. Okay, relation is a subset of Cartesian. Okay, that is what in relation we collect some particular type of ordered pair from A cross B, which are related to each other. Okay, so we can say that relation is a subset of Cartesian. Okay, suppose we consider two sets A cross B, then a relation R from a set where A and B are non-empty sets. Okay, relation R from a set A to B is a subset of the Cartesian product A cross B. Okay, here the first element of A is called the domain of the relation, and second element is called the codomain of the element. Okay, second set is called the codomain and first is called the domain. Okay, and the elements of the second set is called image and element of the first set is called pre-image. Okay, so we can define R like as R is a subset of A cross B. For example, see that suppose R is like that one comma 2 minus 2 comma 3 and half comma 3. Okay, suppose this is a relation, then domain of this relation is what? Domain of this relation, domain is what? Domain is the first element, collection of the first element of R. Okay, so domain is also a set. Here see that first element of R is what? First element of R is what?
1.
What? Or not, you are trying to tell something.
Ma'am, 2.
What?
2.
First element. I said the first element of R. R is this one. 1 comma 2 minus 2 comma 3 a half comma 3. Now tell me first element of R. What are the first element of R?
Ma'am, 1 and 2.
First element, this one is the first ordered pair. Okay, this one is the first ordered pair 1 comma 2 and can you tell me the domain of this R? Domain of R is what?
1.
1.
minus 2,
1 minus 2 and half.
half.
Understand? Domain is
Yes,
what?
ma'am.
It is nothing else. It is the collection of the first element. First element of the ordered pairs of R. Here see that first ordered pair is what? 1, comma 2. Okay. And first element of this ordered pair is what? First element of this ordered pair is what?
1,
1. And the first element of the second ordered pair is what?
minus 2,
Minus 2. And the first element of the third ordered pair is what?
half.
Half. So domain is what? 1, comma minus half, comma half. Okay. And the second element of the ordered pair is called the range. So range is what? Here see that second element of this one is what? Second element of the first ordered pair is what?
2,
2. And for the second ordered pair it is
3,
3. And the for last one?
3,
For the last one it is
3,
3. So range will be what?
2 and 3.
2, comma 3. Range
Sorry.
is what? Range is the collection of the second element of the ordered pair. Understand?
Yes, ma'am.
Understand or not? Just see the relation. Okay, then take the first element of the ordered pairs. This gives you the domain, and take the second elements of the ordered pairs, which gives you the range. Okay. Suppose a relation may be represented either by the roster form or set builder form. Okay. Suppose number of elements of A has P and number of elements has Q. Then the number of elements of the then the number of relation from A to B is what? To the power P into Q. Okay. Remember this thing also. Total number of Cartesian product is what? P into Q. Okay. And total number of relation is what? 2 to the power P into Q. Understand?
Yes, ma'am.
Suppose here, see that. Here, from this one we cannot say because here A and B are not identified. So we cannot tell about the total number of relation. Okay. So condition is what? Formula is what? Formula for finding the relation from a set A to B is what? If A has P elements, B has Q elements, then the number of relation from A to B is what? To the power P into Q. Okay? Understand? And the number of Cartesian product is what? Only P into Q. Okay? Understand?
Yes, ma'am.
And take some example. Here this. See this example. A equals to 1 to 3, comma 4 and B equals to 5, comma 7. And find A cross B and B cross A. Is A cross B equals to B cross A? A cross B equals to B cross A. Is it true? I have already told you.
Not true, ma'am.
Not true. Because it is for any kind of sets, it is not true. Okay. So, question is arise like that one. Suppose commutative law holds for Cartesian product. Is it true or false? Suppose I say that
False.
commutative law holds for Cartesian product. Is it true or false?
False.
Yeah, it is false. Okay. Now from these two sets, A equals to 1, comma 2, comma 3, comma 4, B equals to suppose 5, comma 7, comma 9. Can you find A cross B? It is easy. Can you find A cross B?
Yes, ma'am.
Okay, for A cross B, first you have to take the first element of this set because we are trying to find A cross B. So we have to take first we have to take the elements from A. Okay, so it is look like as what 1. First element of A is what? First element of A is what?
1.
1. So we start from 1. So it will become as 1 comma 5. Then next one is what?
1, comma 7.
1 comma 7. Then
1, comma 9.
1 comma 9. Okay. So we stop for 1. Okay. Then we after that we start from 2. Okay. So it will be what?
2, comma 5.
2 comma 5.
2, comma 7.
2 comma 7 and
2, comma 9.
2 comma 9. Similarly, we are done for 3 and 4 also. Now, can you tell me the number of elements in A cross B? How many numbers are there A cross B? That is total number of Cartesian product. Total number of elements in this Cartesian product is what? N of A cross B will be what?
12.
12 because A has 4 elements, B has
3 elements.
3 elements. So numbers of elements in A cross B will be what? 4 into 3. This will be what? 12. Okay. And the number of elements in B cross A will be what?
12.
12. So 12, it is what? 3 into 4.
4.
3 into 4 is 12. So we can say that n of A cross B equals to n of B cross A. But A cross B does not equals to B cross A. Okay. Understand?
Yes, ma'am.
Okay. Okay then. Now see this problem. Find x and y. See this one. This is also a ordered pair and left-hand side is also a ordered pair. From this one, can you find the value of x and y? Using what condition?
Yes.
What condition will be applied? Finding the value.
Order pair.
Yeah, ordered pair. Because we know that this is also a ordered pair, this is also a ordered pair. Both are equal. In the given problem, we are given that these are equal. Okay, and we have already know about that. Two ordered pairs are equal when their corresponding elements are same. Okay, understand?
Yes, ma'am.
So from this one, what we write? 4x plus 3 equals to thrice x plus 5. Okay, so from this one we can write 4x plus 3 equals to thrice x plus 5. Okay, understand?
Yes, ma'am.
And see then y is what? Without any calculation, directly we say the value of y. Now tell me what is the value of y?
-2.
Y is minus 2. Yeah, correct. Because this one, y equals to minus 2. Okay. Similarly, you can try this example also. Okay. So try to solve this problem. Write this one. Write this one. This one is your homework. If write that one, all of you, Meba, Noor, hello,
Yes, ma'am.
yeah, write this problem. If A equals to 2, 4, 6, 9 and B equals to if A equals to 2, 4, 6, 9. Have you right? Hello?
Yes, ma'am.
Have you write this one? If A equals to 2, 4, you have to submit this problem in your group. After solving,
Yes, ma'am.
take a photocopy and after that you submit it in the group. Image file in the group. Okay? So write the problem. If A equals to 2, 4, 6, 9 and B equals to 4, 6, 18, 27, 54. And A is what? A belongs to, small a belongs to A, capital A, and small b belongs to capital B. Find the set of ordered pairs such that A is a factor of B. Here condition is also given. Condition is what? A is a factor of B and A less than B. A less than B. Try to solve that problem. Okay? I think all of you write that problem. Okay then, for today I will stop and try to solve this problem and after that take a photocopy and it will be submitted in the group. Okay?
Yes, ma'am.
Okay then, let's stop for today.